Hello, I'm Teacher Lu. Let's begin our MPBOT 609 training. Today, we'll walk through the basics you need to know. First, it's a very unique product that can be programmed without a computer. This micro-brain programming is primarily achieved through the controller on top. Next, we need to understand how it integrates with some of our core electronic components. Let's first look at the parameters of the core components. The core of the product is the controller I just mentioned. It's equipped with 2 motors, mainly for driving the robot's movements, and 2 spindle boxes for motion transmission. It has an infrared sensor, also known as infrared obstacle avoidance, and a sound sensor, also known as a sound intensity sensor. It is equipped with 2 light modules, one red and one green. Furthermore, we have 109 LEGO 9656 set compatible bricks to assist it in the visual design of some projects, as well as the implementation of robot transmission. With these core components, we can program robots. These are pictures of the core components. Let's get to know them together. This is the controller. You can see it has different ports on top, which we can connect to control our electronic components. There's also a charging port on the side. The surface has many programmable buttons. Then we have 2 motors. The motors look similar to the spindle boxes, but they look different from the back. The motors provide power, allowing our robot to move. And these 2 are the spindle boxes, which transmit power to both sides. This is an infrared sensor, with both a transmitter and a receiver. It connects via a Type-C port and can be connected to the controller. This is a sound sensor, which senses sound volume to make judgments. It also has the same port on the back. These 2 are red and green lights, respectively. They also have the same ports on the back. Furthermore, the structure above can be built onto the big block. We also provide 2 types of cables to these core electronic components. This MPC controller is like the human brain. Let's take a look at its appearance to get a basic understanding of this controller. The controller has many different buttons for programming. The side features the switch and charging port. Here's the screen, used to display the program. The top has 4 ports for connecting electronic components. To use it, first press and hold the power button for 1 second. The screen will light up. However, if it's your first time using it and pressing and holding doesn't work, it's possible that a small plastic piece on the back was installed during transportation to prevent accidental activation. This needs to be removed before use. Please note this. After powering on, we can use these buttons. There are several types of buttons. First, the first row is for single motor rotation, and the second row is for dual motor rotation. Here are the sensor buttons. Here are the lights. Here is the buzzer. And then there are buttons for repeat execution, speed adjustment, etc. Note that this is the mode button, which we will learn about in detail later. On the back of the controller, we can see some round holes. The battery is located there. These round holes allow it to be freely assembled into our big blocks. That's a basic understanding of the controller's appearance. Now, let's continue to learn more about the controller. Let's look at the interfaces above, which are A, B, C, D. Although these interfaces look the same, they have a functional distinction. There's a 1-to-1 correspondence principle when wiring. Interfaces A and B are mainly used to connect motors, while interfaces C and D can be used to connect additional actuators and sensors, such as lights, infrared sensors, and sound sensors. Therefore, we must connect them according to their corresponding rules. If we plug a motor into interface C, you'll find that it doesn't move, so we need to distinguish between them. Secondly, there's the switch, which is both for turning the device on and off. If you press and hold it for 1 second, it turns on and the screen lights up. If you continue pressing and holding for another second, it turns off. Then there is a charging interface on the side, and its cable is also Type-C. The battery is located on the back, and we don't usually need to remove it. The first time you use it, you need to remove the small plastic piece before it can be used normally. There are 3 modes: real-time control, key screen programming, and Bluetooth connection. Let's learn about the first mode, real-time control. In real-time mode, you need to switch the mode button to the left, corresponding to the icon on the left. In this mode, the buttons shown on the image are usable. Motor A rotates in reverse and forward. Motor B rotates in reverse and forward. Forward, backward, left turn, right turn. Also, buttons for lights C and D, and the buzzer. So why are these buttons usable in real-time mode? Because, as we've discussed, actuators perform functions, performing a motion function, turning on a light, or making the buzzer sound. So, in real-time control mode, the actuators are functional, and correspondingly, these buttons on the controller appear to be functional. Why are the 2 middle buttons, which also look like motion buttons, ineffective when pressed? Because they are actually for stopping, and when stopped, they are not moving, so they are invalid. In this mode, if I click to reverse motor A will turn when I press the button. However, it will stop turning when I release the button. So, it outputs a result in real time and stops when I release the button. The light is used to execute a command to turn on, and the buzzer is used to execute a command to emit a sound. These are useful in our real-time control mode. However, conversely, a sensor's primary function is to receive external signals, then make judgments based on this data, and then perform other actions. Therefore, it receives and outputs signals rather than directly executing commands. Thus, the sensor is useless in this mode. Pushing the mode button to the left activates a real-time control mode. We can connect these cables to the interfaces on the top of the controller. We can see that motors A and B are connected to ports A and B. The infrared sensor and light are connected to ports C and D. If connected incorrectly, they won't operate. Now let's observe which buttons are functional in real-time control mode. Let's take a look. Note that this one is connected to port A, so clicking motor A will make it rotate. Therefore, these 2 buttons are active in real time. Corresponding icons will be displayed on the screen. Clicking B also makes it move. Okay, we can see that both single and dual motors can be controlled. However, the 2 buttons in the middle are inactive because they are stop buttons and don't move. Therefore, they are invalid. Here's the infrared sensor. We can see that it also doesn't move in real-time control mode. But for the light, note that my light is connected to port D, so pressing D will turn the light on, and releasing it will turn it off. Pressing the buzzer will make it sound. However, the other buttons have no actual response. When we move this button to the middle, we select a key screen programming mode. We can see that when you push it to the middle, an icon like this appears on the screen. Then the screen quickly moves to the next area, which displays the programming module. This interface indicates that we can start programming. We can see that this is the initial display. Then, when programming, whatever program you press will appear on the screen, line by line. We can program up to a dozen pages, so hundreds of lines are no problem. It's worth noting that, generally, during programming, a thick line will appear below the icon of the last programming button. This indicates that the program will continue from there. In programming mode, this line also tells us that you are programming, not running the program. Therefore, we will understand when programming and running the program in the demonstration later. It's actually quite simple. Just look at the line below. Is it a dotted line or a thick line? If the line is dotted, it means the program is running, and you cannot modify it. You must exit the program to make changes. If the line below is thick, it means you are editing, and you can continue writing the program. Okay, let's look at this in conjunction with the controller demonstration and further understand the key screen programming mode. The screen is currently in real-time mode. Now, I'll push the button to the middle, and you'll see the icons on the screen change, entering the programmable interface. This means we've switched to key screen programming mode. These are the buttons that can be programmed. I just connected the motor A and motor B here. Port C is connected to the infrared sensor, and port D is connected to the light. We can try out the usage of each button in turn. For example, now I want motor A to rotate. This is forward rotation, meaning it will rotate clockwise. This is reverse rotation, meaning it will rotate counterclockwise. When I click it, the screen will show forward rotation for 1 second. Then, if I click the Run button, it will rotate for 1 second and stop. And this is the Delete button. If I've written a program and want to delete it, you see, I can't click it directly, right? So, what do I need to do? I exit the program using this button. When we see a thick white line appear below the icon on the screen, we can delete the program. Next, I can make motor A rotate clockwise for 1 to 9 seconds by clicking the button 1 to 9 times consecutively. If I wanted to rotate continuously, I can click the button 10 times quickly. When the icon turns into an infinity symbol, it will rotate continuously. Then, click Run. The motor will keep rotating and will not stop automatically until I click Stop and enter the mode shown on the screen, which means it stops. This is the movement of a single motor. If you want motor A to rotate clockwise, press this button. To rotate counterclockwise, press this button. The same applies to motor B. This button is used to stop and can be used in conjunction with other buttons. If I want both motors to rotate simultaneously, I can delete this first. This is the forward icon. This is the backward icon. This is the left turn icon. And this is the right turn icon. The principle is that the two motors move in different directions. I will now show you how to move forward for 1 second. Okay, actually, during operation, this motor rotates clockwise, and this motor rotates counterclockwise. So why are their directions different? Because generally, when we build a car, we build it to both sides. So the directions are different. Then we can write out the forward, backward, left turn, and right turn commands, and then run them. It starts by turning inward, then leftward, then both to the left, and then both to the right. In this case, we are essentially programming the different directions of two motors. Similarly, if we want continuous motion, we can click 10 times consecutively. Next, let's look at the infrared sensor connected to the C port. First, delete the previous program. Now the infrared sensor is connected to the C port. When I click once, an icon consisting of several small circles appears on the screen, indicating that I'm currently using the infrared sensor. Then, if I trigger the infrared sensor, click this button to make it rotate for 1 second and then click the Run button. It will wait to run the program. When an obstacle appears in front of the infrared sensor, it will trigger the program and rotate. Okay, now what if I'm not using the infrared sensor but the sound sensor? I need to reconnect the cable to the sound sensor first. Before writing the program, delete the previous program. Then, still using the C port, I need to click twice quickly in succession, and the sound sensor icon will appear on the screen. Then click the Rotate button, and then click the Run button. Because my voice is relatively loud, it starts rotating. Click Run again. Okay, like before, we can trigger it with different sounds such as clapping or speaking. But note that it must be triggered while the program is running. That's how to use the sensor. If you are connected to the D port, you can use this button to program it. Let's take a look at these two lights. The lights also have C and D ports. The green light we just saw was connected to the D port. You only need to press the D button once, and this icon will appear on the screen. Pressing it twice will turn it off. If I run it like this, it will just flash briefly because there's no interval between turning the light on and off. We can modify it slightly. If we want the light to be on for a while, we can press this button and then turn it off. Then we can run the program. This way, we can control the light state by the execution time of the intermediate program. And this button is the buzzer. This buzzer is built into our controller. Let's try out the buzzer's effect. When you click once, it programs the note Do. Clicking twice quickly programs the note Re. We can write a short piece of music this way. Okay? It will produce different sounds. For example, if you want to program Twinkle Twinkle Little Star, you can program it according to the sheet music. If you click this button quickly, it increases the pitch. But if you pause or wait while pressing, a new note will appear on the screen. Okay? We can program it this way. Then, if I want to change the speed of the motor, I can click this button to change the speed. This one on the screen is low speed, and this one is high speed. There are two speeds. After changing the speed, the same motion will change. See, when you switch to low speed, it slows down. Okay? This is the speed adjustment button. Okay, so after we've written a lot of code, when we get to the next page, we can use the Page Up button to go back to the previous page, and we can use the button on the left to move and select the area we want to operate on. For example, we can select a program icon and then delete it. Then there's a small part of the controller buttons here. Our loop hasn't been used yet. Okay, let's clear the code first. We'll write a loop at the very beginning of the program and an end loop at the end. Clicking twice will loop twice. Then, we'll add a 1 second rotation of the motor and then end the loop. This program will make the motor rotate continuously for 2 seconds. If we want it to loop 8 times, it will rotate for 8 seconds. Clicking once will loop continuously. If you click the button quickly, you can change the number of loops. When we switch this button to the right, we can select the Bluetooth connection mode. This requires 2 controllers to work together. One controller acts as a controller party, and the other as the remote controller. For example, if I have a robot car on the ground, I don't need to press the programming button on the ground to control it. This frees up our hands, right? Okay, so here. Let's understand the steps for Bluetooth connection and the mutual control relationship between the 2 controllers. Let's look at this slide. First, we have the first controller, and we need to switch its mode to the right to Bluetooth connection mode. Second, the second controller also needs to be switched to Bluetooth connection mode. Both controllers must be in the same mode. If the mode isn't both set to Bluetooth connection, they cannot connect. Third, we need to select which one is the remote controller and which one is being controlled. If I want to use the second controller as a remote controller, I need to click the Run button on the second controller and then they will connect. Each of our controllers has a unique serial number. During connection, a successful connection icon appears on the screen, indicating a successful connection. However, if the connection fails, you need to analyze the situation carefully. Bluetooth connection is a pairing process. If a third or more controllers appear within close range, there may be multiple options, making it difficult to choose. Therefore, in Bluetooth mode, we need to maintain a one-to-one connection. For other, non-connected devices, their mode needs to be changed to a different mode. Otherwise, incorrect connections or connection failures may occur. If there are only two controllers nearby, a connection will be quickly established. This is an important point to note. For Bluetooth connection mode, first switch the mode button on this controller to the right. You'll see a Bluetooth icon and a serial number appear on the screen. Then use another controller. This is controller 1 and this is controller 2. Switch controller 2 to the right as well. Now, both controllers will display the same icon on their screens. I can set controller 1 aside and use controller 2 for remote control. I just need to press this button. A new icon will appear on the screen indicating a connection has been established. The serial number will also disappear, indicating a successful connection. In this case, I don't need to press controller 1. I only need to press controller 2. For example, pressing the button on controller 2 will allow the robot to operate normally. This mode allows the controller to be detached from the robot for remote control via Bluetooth. Any command that the robot itself performs can be remotely controlled via the second controller. To make the structure made of building blocks move, it needs power transmission from our motor. The motor has two different modes, high speed and low speed. We can see a small icon on it. Pointing to the right indicates high speed, and pointing to the middle indicates low speed. Different speeds can be selected depending on the project. For example, for a carousel which needs to rotate slowly, we can choose the low speed. It's important to note that when a controller is turned on, it defaults to high speed. You can switch the speed using this button. If you turn it off and on again, it will revert to high speed regardless of whether it was previously set to high or low. This speed selection can be made before running the program. You cannot change it during program execution. Otherwise, the program will exit. We can see that the first icon on the left of this image is the motor power. The middle one is the current mode. And the upper right corner shows the remaining battery power. It's worth noting that if the robot makes a dee-dee-dee-dee sound, it's likely because the battery is too low. It will automatically sound an alarm to remind you to charge it. We do not recommend operating our robot when the battery is low, as some sensors may not be as sensitive or the motors may not be functioning at full capacity. Therefore, we suggest charging it beforehand. Regarding charging, there's one more thing to note. If we connect it for charging, there's a charging protection mechanism. The controller cannot be turned on while the charging cable is plugged in. Next, there are a few basic operation buttons, such as left moving, page turning, delete, and run. Left moving is mainly used when writing code. For example, If I've written the 8th line of code and want to delete the first one, I can click left moving to select the first line and delete it. Page turning is used because we might have many pages in a program. For example, if I'm on the 3rd page and want to modify the code on the 1st page, I can page down. It only goes down. If I'm already on the 3rd page, clicking down again will return me to the 1st page. It's a loop. The delete button deletes the program. The run button has 2 functions, running and exiting the program. If I finished writing the program and click run, it will start running. If I finish running the program, or if it's running, clicking this button will exit. It's important to note that all editing programs can only be performed after exiting the program. Next, let's look at the motors. Ports A and B are mainly used to connect different motors. For example, if you connect a motor to port A, it will be designated as motor A. If you connect it to port B, it will be motor B. When using it, make sure the interface corresponds to the motor. Some students might connect your motor to port B when it's supposed to be motor A if everyone writes the same program. The robot's movement will be different from others, so this requires careful matching. Another important point is to ensure the connection cable is fully inserted. If your motor doesn't move despite your program, it might be because the connection cable isn't securely plugged in. The motor is controlled primarily through a cross-shaped hole on the side. You can connect components via an axle to make it rotate. This cross-shaped hole is like a clock hand, with clockwise and counterclockwise directions for rotation. So, regarding motor control, firstly, as mentioned, the power is adjustable, allowing you to choose between high and low speeds. Secondly, we can control its direction of rotation. This is clockwise rotation, which we call motor A's forward rotation. And this is counterclockwise rotation, called motor A's reverse rotation. In key screen programming mode, clicking this button once makes motor A's rotate for 1 second. If I click it quickly multiple times, for example, 8 times, it will rotate for 8 seconds. If I click it quickly 10 times, it will enter a repetitive execution state, rotating continuously. This repetitive execution is usually used in conjunction with some sensors. Otherwise, it will keep running and never stop. Similarly, motor B also has forward and reverse rotation. The middle icon button is used to control the stopping of motors A and B. Stopping is generally used in conjunction with the repetitive execution mentioned earlier. For example, if motor A keeps rotating and encounters an obstacle, I can stop it. So, note that if you click this button once, it stops motor A. If you click it twice, quickly, it stops motor B. Let's look at the movement of a single motor in several different situations. First, in real-time control, pressing the button will cause it to rotate continuously, and releasing it will stop it. Second, in key screen programming mode, suppose the programming is as follows. Motor A rotates in reverse for 2 seconds, then in the forward direction for 5 seconds. Then motor B rotates in reverse for 2 seconds, then in the forward direction for 6 seconds, allowing for a fixed duration of movement. Third, if you click the button 10 times consecutively, it will rotate continuously. Fourth, if it rotates continuously and then encounters an obstacle, it will stop. These are some of its different uses. Next, let's look at how to use the dual motors. The dual motors on our icon represent forward, backward, left turn, and right turn. We can see that the icon looks a bit like a car, right? It means you can assemble the product into a car shape to perform these movements. But its fundamental principle is that two motors are assembled back to back. If one motor moves forward and the other backward, they create corresponding movement trends. So, when we call it forward, the underlying principle is that motor A rotates in reverse, and motor B rotates forward. Both rotate simultaneously because they are assembled back to back, creating a forward effect through the alternating forward and backward motion. However, I don't necessarily have to assemble it into a car shape. If I have two separate motors, I can control them to turn in different directions simultaneously using this button. Moving backward reverses the rotation of the two motors. The same applies to left and right turns. For left turn, motors A and B rotate forward simultaneously. For right turn, motors A and B rotate in reverse simultaneously. During use, some students may encounter the issue where other students' robot cars move forward when the forward button is pressed, while theirs moves backward. This is most likely because the wiring of motors A and B is reversed. This reverses the rotation direction, causing other students' robot cars to move forward, while yours moves backward. Therefore, you need to check this connection. Here are some programming examples for dual motors. The first is in real-time control mode, where clicking a button triggers movement. The second is programming it to move forward and then backward. The third is to continuously click the button 10 times to make it move forward without stopping. The fourth is often used in conjunction with sensors, allowing it to keep moving forward and then stop when encountering obstacles, etc. These are all common examples. Next, let's learn about the two sensors, the infrared sensor and the sound sensor. We can see C and D next to these buttons. If you plug the sensor into port C, use the first button to program it. If you plug it into port D, use the second button. For example, we often program the model to run continuously and then stop when it encounters an obstacle. However, it's important to note that you might get an X mark for several reasons. First, the connection cable might not be plugged in properly, so it's not being recognized. Second, you might have plugged in a sound sensor, but you've programmed it to use an infrared sensor to receive information, and it might not be matched. Third, you might have plugged a cable into port D and tried to find an infrared sensor from port C, which also won't work. Therefore, you need to check if the sensor and interface are correct and if the cable is plugged in properly. After connecting the cable to port C, clicking the button once will default to using the infrared sensor. Quickly clicking twice will use the sound sensor. The infrared sensor has a limited effective working distance. For example, if it exceeds the effective working distance, it might not detect obstacles. Sound sensors are generally quite sensitive. Even a slightly loud sound can trigger them, such as clapping or speaking. Let's look at some examples. The first one has already been mentioned. The second program involves the motor starting to rotate when an obstacle blocks the infrared sensor. The third program involves the motor rotating continuously until a loud sound is heard, at which point it stops. Next, let's look at the lights, which have red and green lights. The lights are accessed through interfaces C or D. Clicking the button once turns the light on, and clicking it twice turns it off. It's important to note that turning the light on and off uses the same port, following a one-to-one matching principle. Let's look at some programming examples. The first program turns the light on and then turns it off. It will show a phenomenon where the light is on for 0.01 seconds because there's nothing happening in between. It's immediately on and off. The second program will show the light turning on first. then the motor running for that 1 second while the light is still on, and then turning off when the motor stops. So, this results in the light being on for 1 second. Then the third program will repeatedly switch between the two states of the light being on and off. That is, it will keep flashing rapidly because I added a repeat execution at the beginning. Another important function is the buzzer, but it's not presented as an electronic component because it's integrated into the controller. This button primarily controls different tones. We often use the buzzer and lights as intervals. Motor movements typically include whole seconds, 1 second, 2 seconds, etc., and continuous motion, but sometimes we want finer precision, such as making the motor rotate for 0.1 seconds. This finer control can be achieved by adding an interval between two actions. Generally, a buzzer takes about 0.1 seconds to produce a sound. So we can have the motor move first, then the buzzer sounds, and then the motor stops. This achieves the effect of 0.1 seconds of movement. Similarly, a light stays on for about 0.01 seconds. Placing the light in the middle will create the effect of the motor moving for 0.01 seconds and then stopping. Let's look at some examples. First, we can use the buzzer to create simple music, like Twinkle, Twinkle, Little Star. Second, as I just mentioned, placing the buzzer as an interval between repeated rotation and stopping will create a 0.1 second interval. The third example uses the light as an interval with the motor rotating for 0.01 seconds and then stopping. Finally, let's look at loops. A loop generally includes a start and an end. These usually appear in pairs. Actually, when you only have one loop, whether or not you specify an end doesn't affect its functionality. However, we might encounter nested loops, meaning a program might have several levels of loops. In this case, we need to specify a start and an end for each loop to maintain the looping relationship between them. Therefore, it's important to maintain good coding habits. Every loop has a start and an end. Let's look at some examples. In the first program, every time the infrared sensor encounters an obstacle, the motor rotates for 1 second and then stops. The next time something blocks the way, it rotates for another second and stops, repeating this process. In the second program, the motor is initially stopped. When an obstacle appears, the motor rotates. The buzzer is used as an interval, as mentioned earlier. Without it, the motor would start immediately and stop abruptly in the next cycle, resulting in the robot constantly jerking, creating a strange phenomenon. Therefore, when using sensors for repetitive execution, an interval must be set. If we want the robot to move when a hand blocks the way and stop again when a hand is blocked again, this is a common programming requirement. In that case, we can write it like the third example. When an obstacle appears in front of the infrared sensor, the motor continues to rotate, but there must be at least one interval. Don't jump directly to the next program instruction. If your hand is blocking the way as an obstacle and you haven't removed it before starting the next program, it will create a chaotic effect. This 0.1 second is mainly to allow us to retract our hand. Okay, when the second obstacle appears, the robot core stops. What should we do next? Add a buzzer to create an interval, then end the loop, giving it a beginning and an end. This would be more suitable for our needs. The above is our learning of some common programming concepts and examples. Okay, that concludes all the training content. Thank you for watching.